the limit looks like this. What does it mean? The radius interval x plus or minus c less than some tiny positive number delta will result in your y value plus or minus L being less than some tiny positive value. That's what the definition of limit is, like whatever that is, right? But picture-wise, you remember this picture? This is straight copy out of your BC note. Okay, so this is C, and that happens to be L in this case. So C is 4 plus or minus delta, whatever that little gap is, right? So if your specification is 0.1, then I can just squeeze this down so that make it smaller to fit with inside. And we can have the same idea with a curve as well, right? This is C plus or minus delta, and these two are not necessarily the even interval, but if we pick whichever is smaller, then we can squeeze this thing down. You know what I'm saying? Somewhat remember this? I mean, we don't have to prove it, but do you remember the picture? So I can make F delta small enough so I can squeeze this down. How does that translate to multivariable situation? If you have a two-variable function, which is quadratic surface that you guys sketched already, right? How does that look like? If z is function of x and y, what does that picture look like? Okay, that's the same picture. It looks like this. Your input, your domain is xy plane, isn't it? People call that as r squared, r by r. You get it? So R squared is a two-dimensional space, which is XY plane, picture-wise. It doesn't have to be, but that's the easiest way to picture this. And your output is the Z-axis. You get it? So whatever the point here on this surface will map to, it's like this is a point, and that there's a corresponding point on Z-axis. You get it? Now, then how do you, instead of that little interval now, it gets a little tricky. Here is easy. L plus or minus epsilon is easy. You just move up a little bit, move down a little bit. But how do you squeeze this thing down? We have to do it on a disk, or sometimes neighborhood. Some people call it ball or whatever, right? So if we put a circle around and make that circle smaller, can you animate that? Then that gap is being reduced to that point, and there may or may not be a hole here. That is the concept of our limit. And epsilon delta wise, so this side looks exactly the same, but this side, you see that's the equation of a circle now, isn't it? If that thing E is equal to R, that's an equation of a circle, A, at a location A, B. So that our circle's radius is, of course, delta, and we're going to squeeze that down to make this thing, right? Okay, and then you notice that the limit xy coordinate approach is AB coordinate. You know what I'm saying? And still, this value is 1. Okay, so let's take examples now, shall we? Okay, this one is a nice example. Now I'm going to switch live. So let's take that example. So if we have this function, f of x and y, is equal to x squared over x squared plus y squared. Now, generally, for nice, well-behaved function, limit exists everywhere, and we can just substitute. No problem. You know what I'm saying? So what's the only potential place that could create a problem for us? Is at the origin, isn't it? If x and y are both 0, then your denominator is 0, isn't it? Well then, if x is equal to 0, your numerator is 0. So once again, we are facing this 0 over 0 situation. What is it in this case? You know what I'm saying? So what do you say? Should we take a look at this beast? Yeah, let's do that because I have this thingy. Okay, let's try to graph this thing. So I have z is equal to x squared over, no, not like that, outside over x squared. No. This is so difficult. Really? There. Plus y squared. You ready? Boom. What color do you want? Is this better to look at? Let me zoom in a little bit. Zoom in, I said. Oh, that's too much. This thing is a little weirdly folded thing, and there's some kind of, okay, there's a hole. This looks bigger than, is this better? Right, there is a hole, but, well, then if it's a hole, limit exists, right? Not so fast. See, different level. At this side, the z value happens to be 0, isn't it? Because this is the axis. Here's your x and y axis. So from this direction, positive y axis direction, your z value, your value of the function is 0. But if you come along the x direction, that's your x axis, that way, that is way up there, something that is not 0. So this is a little weird case now, isn't it? There's a little, this quadratic surface is not uniform and smooth. It's folded in a weird way, and there's a small tear on top. So we don't expect the limit to exist in this case. You know what I'm saying? Okay, but how can we show it? Well, first, let's say if y is equal to 0. In other words, f of x comma 0. You know what I'm saying? What is this thing? Well, that is x squared over x squared plus 0 squared, eh? Which is equal to 1. So far, so good. And then we have to say, once we cancel this, of course, x is not equal to 0, eh? But we are approaching 0. Y can't be equal to 0 as long as x and y are not both equal to 0, then we are okay, eh? Because the denominator is not 0. So as x approaches 0 now, along the x-axis from our picture, and then your f of x approaches 1. You know what I'm saying? Let's go back to the picture. So this height, that ridge happens to be height of 1. You get it? Okay, now come back, but when x is equal to 0 now, in other words, this is f of 0y along the y-axis. Now, let's see what it is. So we have 0 squared over 0 squared plus y squared, which is equal to 0 as long as y is not equal to 0, eh? So what happens is, as y approaches 0, your f of 0y will approach 0. You get it? So we have two different values. Remember, in order for the limit to exist, the left limit, right limit, according to last year, when there was just left and right side, they must agree. Well, in this case, they must agree in all directions, right? Not just x and y, right? But they have to agree in all possible directions along any path to that origin. So in this case, we have a contradictory result already, right? So we can say, therefore, the limit does not exist. You get it? Showing some limit doesn't exist is easy. Okay, let's look at the next case. Okay, next case is this. Our f of x, let's call it g of x, is equal to 3x squared y over x squared plus y squared. Shall we examine this a little bit? Okay, so if x is equal to 0, so we have g of 0 comma y. What do you have? You have 0 over y squared, eh? Which is 0. So if you approach this along y-axis, as y approaches 0, your f of g of 0y will approach 0 then, eh? Okay. What about when y is equal to 0? So g of x comma 0, that's still 0 because you still have y in the numerator here over x squared, isn't it? That's equal to 0. Oh, I still have to mention that here y is not equal to 0 and here x is not equal to 0, eh? What that means is as x approaches 0 now, y is already equal to 0, then this thingy will approach 0. So they agree. Is that enough to prove that limit exists and that limit value is 0? No, it's not. Because that's just x-axis and y-axis. We don't know. I mean, in the book, they have an example of y, x is equal to y direction. I mean, all kinds of weird direction. We have to prove it in all directions. But we don't want to do epsilon delta proof here, right? So it's like, how are we going to manage this? Shall we take a look at the picture first? Yeah, we shall. So this beast, all I have to do is put 3 here and wait at the end. I'll just put y in front. Y. No, not t. Y. Okay. What this beast looks like. You see, there's a uniformity. More the reason to believe that limit exists, and that's 0. There's a hole right there. And then in all direction, no matter where you approach this, it's going to give you 0, eh? So we have a reason to believe that limit exists and that limit is 0. But how can we show this? This is not good enough. Many people just do this on the test and say, no. Right? So there are 2 ways of doing it. One way is this. That function, which is 3x squared y over x squared plus y squared. This is between absolute value, because if any of these things could be negative, we have seen it on the graph. Now, what happens if I just make this y in the denominator 0? Okay. Do you agree with this inequality? You definitely agree because it's absolute value. Do you agree with this inequality? Because I'm making denominator smaller because y squared is positive. So if that is 0, but notice that I'm not really setting entire y to be 0. I'm just reducing the denominator. Okay, why would I want to do such a thing? Because this thing will reduce to then 3y absolute value. Do you see the squeeze theorem coming? Yeah. So now I'm going to take limit of xy approaching 0, 0 of 0. Why did I put it there? 0 and less than equal to limit of xy approaching 0, 0 of that thingy 3x squared y over x squared plus y squared, and inequality limit of xy approaching 0, 0 of 3y. Oops. You know what I'm saying? Now this thing becomes 0, and this thing becomes 0, doesn't it? And the middle, I'm going to do copy and paste. One advantage of this distance learning, copy and pasting is a lot easier than real actual whiteboard. You know what I'm saying? So only possible conclusion here is pasting more time. This limit that we want must be 0. How about that? You get it? That's one way. There's an alternative. Here's an alternative. An alternative is this. I'll paste this one more time. And that alternative is actually, can somebody suggest a beautiful alternative here? Why did I ask? We go into different coordinate system. Now, is that enough hint for you? Instead of Cartesian XY coordinate, we go to, there's only one other possibility. We are in two-dimensional space. Okay, this whole function is 3D, but your domain is two-dimensional space, X and Y. So instead of Cartesian, what else is there?
Polar.
Polar. Okay. The denominator first. What's the x squared plus y squared? That's r squared, isn't it? Actually, you know what? I don't think I even need this. I don't think I even need this absolute value. I think I can do it without. And then, of course, this is 3 r squared cosine squared theta. So far, so good. And then your y is r sine theta, isn't it? And x and y squeezing down on a disk or circle, that just means all is approaching 0, eh? And it's irrelevant of theta. There's theta doesn't get affected by the limit, and theta still has a freedom to rotate 0 to 2 pi, so this covers all direction. You know what I'm saying? So let's simplify this. So this is limit as r approaching 0 of, what do you have? 3 r cosine squared theta sine theta. Is that what we have? And then as long as r is not equal to 0, but do I even need to write this? No, I don't, because when we say limit, it means r is not equal to 0 anyway, right? Okay, so now this r approaches 0 and there's no more denominator to worry about. That's the entire limit is 0. How about that? As we suspected from the beginning. So all of your homework, either you can do it with the squeeze theorem or you can do it with polar coordinate. Whichever seems to be easier. One is usually easier than the other, depending on the problem. Okay, any